Welcome to In 5 Minutes. Let us discuss the next numerical now. The question says when the modulation percentage is 75, that means capital M or modulation index in percentage is given as 75. That means small m will be equal to 0.75. So small m is equal to 0.75. And the question says the AM transmitter produces 10 kilowatts. When we say that AM transmitter produces 10 kilowatts, that means that's the total power which the transmitter is producing. So PT is given as 10 kilowatts. Now the question is, what would be the percentage power saving if the carrier and one of the sidebands were suppressed before transmission? That means currently the question talks about transmission of double sideband full carrier, but now the question says what should be the percentage saving in power if instead of everything we transmit only single sideband. That means one sideband is suppressed and a carrier is also suppressed, so it is suppressed carrier signal that is being transmitted. Let us understand one thing, that when you transmit DSB-FC signal, we transmit upper sideband power, lower sideband power and the carrier power. These are three power values we transmit. But when I transmit single sideband, I just transmit one of the three. That means the carrier is suppressed, and let's say we suppress lower sideband, so I'm transmitting only the upper sideband. So what will be percentage saving in power? The percentage saving in power will be nothing but power saved divided by total power which we otherwise transmit into 100. Power saved is any one sideband power, let's say upper sideband power. Total power is PT, which is sum of all the three powers, into 100 will be my final answer. So let's find out these values one by one. In question we already know the total power PT. PT is given to be 10 kilowatts to us. That means we have to now somehow find the sideband power. We know that total power PT is PC into 1 plus m square by 2. So in this case PT is given to us as 10 kilo. PC is unknown, something that we will find it out, and the modulation index value is also given to us as 0.75. So it's 0.75 square by 2. So if I solve this, I'll get the value of PC, which is the carrier power. So the carrier power will come out to be 7.8 kilowatts. So now I need power in the upper sideband. So we already used this formula. The total power is the carrier power plus total power in the sideband. So the total power in the sideband will be PT minus PC, which is equal to 10K minus 7.8K. Therefore, the total power in the sideband becomes 2.2 kilowatts. Now, power in upper sideband or power in lower sideband, whichever sideband power you want, the power is exactly same. It is always the sideband power divided by 2. So that will be approximately equal to 1.1 kilowatt. So we have got upper sideband power and the total power was already available. So I can now apply this formula and find out percentage saving in power. So percentage saving in power is equal to P USB is 1.1 divided by total power is 10, both are in kilo, multiplied by 100.